In this episode, we take a wide-angle view of an artificial intelligence (AI) solution as a full life cycle, from the first idea on a whiteboard to the day it is retired, and we learn how to evaluate compliance and risk at every step along that path. New learners often picture risk as something you check at the end, like a final exam you pass before launch, but real risk is created gradually through hundreds of small choices about purpose, data, design, testing, access, and monitoring. Compliance works the same way because obligations are rarely satisfied by one document or one approval. They are satisfied when the organization can show consistent behavior and evidence over time. The end-to-end mindset is powerful because it prevents the most common failure pattern in AI programs, where teams focus on building the model while forgetting that the surrounding system is what creates real-world impact. By the end, you should be able to walk through an AI lifecycle and identify what good oversight looks like in plain terms. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to frame the life cycle is to think of it as a chain where each link can either reduce risk or amplify it. Early links include defining the purpose, deciding whether AI is appropriate, and identifying who will be affected. Middle links include selecting data, labeling and feature choices, model development and evaluation, and the design of how humans will interact with outputs. Later links include deployment controls, monitoring, incident response, change management, and periodic review that decides whether the system still belongs in the environment it is operating in. Compliance and risk evaluation is not about hunting for perfection in each link, but about confirming that each link is strong enough for the use case's impact level. A low-impact recommendation tool can tolerate more uncertainty than a system that influences eligibility, security enforcement, or access to services. When you evaluate end-to-end, you are always asking two core questions. What harm could happen here? And what proof exists that the organization prevented it in a controlled way? The life cycle begins with ideation and scoping, and this stage is more important than it sounds because it sets boundaries that later stages either respect or ignore. A strong evaluation checks whether the organization clearly defined the purpose, the intended users, and the decisions or actions that will be influenced by the AI output. It also checks whether the organization considered non-AI alternatives, because sometimes the ethical and compliant choice is to use a simpler rule-based approach that is easier to explain and govern. Another key check is whether the organization identified the populations affected, including indirect impacts, such as people flagged for extra scrutiny or people whose content is filtered more aggressively. If the purpose statement is vague, like improving efficiency, risk tends to spread because teams can justify almost any data collection and almost any use expansion. A discipline program makes purpose specific enough that you can tell when the system is drifting away from its original intent. During scoping, compliance evaluation should also look for early classification of impact and risk, because that classification drives how much oversight is required. Many organizations use a tiering approach, even if they do not call it that, where higher impact use cases require deeper assessment, more rigorous testing, and stronger transparency and appeal paths. A practical evaluation question is whether the organization can explain why a particular use case is considered low, medium, or high risk, and whether that classification is tied to real criteria like harm severity, reversibility, and who is affected. This is also where early privacy and fairness concerns should surface, because if the system will use personal data or could create unequal outcomes, those risks need attention before data is gathered and transformed. When programs skip this early classification, teams often discover late that they built a high-impact system with low-impact controls. End-to-end evaluation catches that mismatch early. The next lifecycle stage is requirements and design, and this is where compliance and risk are translated into concrete expectations. Requirements should include not only what the system should do, but what it must not do, such as using certain sensitive data, making certain decisions without human review, or producing outputs that could expose private information. Design should include how the system fits into a workflow, because a model that is described as advisory can become effectively mandatory if people are pressured to follow it. Evaluating this stage means checking whether the organization defines success criteria that match the real purpose and whether it defines safeguards that match foreseeable harms. It also means checking whether roles and responsibilities are clear, including who can approve changes, who can pause the system, and who responds when monitoring detects trouble. If requirements are only about performance, the system may ship fast, but compliance and risk obligations will be handled as afterthoughts. Strong design makes responsible behavior the default. Data acquisition and preparation is the next stage, and it is often the most compliance-intensive because it touches privacy, consent, purpose limits, and potential bias. An end-to-end evaluation checks where the data comes from, what permissions exist, whether the use aligns with expectations, and whether the dataset includes sensitive categories that raise risk. It also checks representativeness and measurement quality, because biased or incomplete data can create unequal outcomes and misleading performance claims. At a high level, you want to see that data is minimized to what is necessary, that retention is defined, and that access is restricted to appropriate roles. You also want to see traceability so that the organization can later prove which data sources were used and how they were transformed. If the organization cannot explain how a dataset was assembled, it will struggle to defend compliance, and it will struggle to correct issues after deployment. Data governance is not separate from the lifecycle. It is one of its central pillars. Labeling and feature work sit inside data preparation, but they deserve special attention because they can quietly turn policy into behavior. Label definitions shape what the model learns as truth, and feature choices shape what signals the model is allowed to use. Evaluating this stage means confirming that label guidelines are clear, consistently applied, and audited for quality, and that labeling does not encode unfair past decisions as if they are objective reality. It also means checking that features do not smuggle in proxies for sensitive traits and do not create leakage by using information that would not be available at the moment the model is used. These are compliance and risk concerns because they can lead to discrimination, privacy exposure, and misleading performance claims that leaders rely on. A strong lifecycle evaluation treats labeling and features as governed design decisions, not as technical chores. When these choices are documented and reviewed, the organization can show that it anticipated risks rather than discovering them after harm occurs. Model development is the stage most people think of first, but end-to-end evaluation keeps it in context. Development includes selecting model approaches, training, and iterative experimentation, and the compliance and risk concern here is not that experimentation happens, but that it happens within controlled boundaries. Evaluation should look for separation between experimentation and production because uncontrolled experiments can create uncontrolled copies of data and unclear version history. It should also check whether the organization uses discipline change tracking so that when a model improves or degrades, the team can explain what changed in training data, features, or objective functions. This is where documentation becomes essential, not as bureaucracy, but as the memory that allows accountability. If the model is being tuned for performance, you also want to ensure it is not being tuned to pass superficial tests while failing on harder real-world conditions. Development is the phase where optimism is highest, which is why governance discipline matters most. Testing and validation is the lifecycle stage where risk should become measurable and where compliance claims should become evidence. A strong evaluation checks that the organization tests performance in conditions that resemble real use, not only in clean lab data. It also checks that testing includes subgroup views where relevant, because average performance can hide uneven harm. For systems that generate content, testing should include safety checks that look for harmful, misleading, or privacy-exposing outputs. For systems that classify or score, testing should include checks for stability, error patterns, and sensitivity to input changes. An end-to-end evaluation also checks whether the organization defined acceptance criteria before seeing results, because criteria created after results can become a form of self-justification. Validation should produce artifacts that decision-makers can understand, such as clear summaries of what the system can do well, where it is weak, and what safeguards are required in operation. Without that clarity, deployment becomes a leap of faith rather than a controlled decision. Deployment is the stage where an AI system stops being a project and starts being an operational risk and responsibility. Compliance and risk evaluation here focuses on access controls, user experience design, logging, and the boundaries of permitted use. If the system handles personal data, you want to see that data flows match what was approved and that retention and access align with policy. If the system influences decisions about people, you want to see transparency and contestability mechanisms that match the impact, such as a path for review when the system is wrong. You also want to see that deployment includes monitoring hooks, because a model without monitoring is like a plane without instruments. A common failure is deploying a model and assuming the job is done, when in reality deployment is the start of the most important period, when the model meets messy real-world inputs and real user behavior. End-to-end evaluation treats deployment as the transition into continuous oversight. Once a system is running, monitoring and operational reporting are the heartbeat of governance. Evaluation here asks whether the organization tracks both performance indicators and risk indicators, and whether those metrics are understandable to leaders who must decide what to do. Monitoring should include signals for drift, uneven outcomes across segments, misuse patterns, and privacy exposure such as sensitive information appearing in prompts or logs. It should also include operational signals like escalation rates, override rates, and complaint patterns, because those often reveal risk before confirmed ground truth is available. Governance usefulness depends on timing and thresholds, meaning signals arrive quickly enough to prevent harm and are tied to triggers that lead to action. An end-to-end evaluation checks whether monitoring has actually caused decisions in the past, such as restricting a feature, retraining, or pausing deployment. If monitoring exists only as passive dashboards, it will not prevent incidents because nobody is compelled to respond. Effective monitoring turns oversight into a living practice. Incident response is another lifecycle stage that many organizations treat as purely security-focused, but for AI it must also include ethical, privacy, and compliance dimensions. An incident might be a privacy leak through outputs, systematic unfair outcomes discovered through complaints, misuse by internal users, or a sudden performance collapse due to drift. Evaluating incident readiness means checking whether the organization has clear reporting channels, triage criteria, and roles that include privacy and governance expertise, not only engineers. It also means checking whether the organization can identify scope quickly by tracing which model version and dataset version are involved. If you cannot identify scope, your response becomes broad and disruptive, which increases operational harm. A mature program learns from incidents and near misses by updating controls, monitoring thresholds, and design constraints. End-to-end evaluation treats incidents as inevitable events to plan for, not embarrassing surprises to deny. The goal is fast containment, honest communication, and systemic improvement. Change management is the lifecycle discipline that prevents today's safe system from becoming tomorrow's unsafe system through small, unreviewed edits. AI systems change when data sources change, when models are retrained, when features are updated, when user interfaces shift, and when the system is used for new decisions. Compliance and risk evaluation checks whether these changes trigger review proportionate to impact, and whether approvals are documented with clear criteria. It also checks whether the organization can roll back to a prior model version when necessary, because rollback is often the safest response to emerging harm. Another key element is whether the organization tracks dependencies, so it knows which downstream systems rely on the AI output and how changes could ripple through the business. Change control also includes vendor changes, such as updates to third-party model services or labeling providers, which can alter data handling and behavior. End-to-end evaluation treats change as normal and governs it, rather than pretending the system is stable forever. A controlled evolution is safer than a silent drift. Periodic review and recertification is the stage where governance steps back and asks whether the system still belongs in its role. The world changes, the organization changes, and what was acceptable at launch may become unacceptable later due to new regulations, new expectations, or new evidence of harm. Evaluating this stage means checking whether the organization has scheduled reviews, such as quarterly or annual governance check-ins, and whether those reviews examine purpose drift, performance trends, fairness signals, and privacy compliance. It also means checking whether the organization revisits the original purpose statement and confirms the system is still used within those boundaries. Another valuable review question is whether the organization has updated training for users, because user behavior and misunderstanding can create risk even when the model is stable. Recertification is not about creating paperwork. It is about keeping trust justified by ongoing evidence. When periodic review is absent, organizations often wake up to risk only after an external event forces attention, which is the worst moment to discover gaps. Retirement and decommissioning is the life cycle stage people forget, but it is essential for compliance and risk because systems do not disappear just because they are no longer popular. An AI system can continue to run in a corner of the business, making decisions without active oversight, and that can create long-term harm. Evaluation here checks whether the organization has criteria for when to retire a system, such as persistent drift, inability to meet fairness obligations, or changes in purpose that make the original model inappropriate. It also checks what happens to data and logs after retirement, because retention obligations still apply and sensitive datasets can become forgotten risk reservoirs. A responsible retirement includes revoking access, removing integrations, documenting the reason for retirement, and ensuring any dependent systems are updated to avoid hidden reliance. It also includes preserving enough evidence for accountability if questions arise later, such as why a decision was made when the system was active. End-to-end evaluation treats retirement as a planned step, not an accident. To close, evaluating the AI solution lifecycle end-to-end is about ensuring compliance and risk controls are present at every stage, not only at the finish line. In scoping, you look for clear purpose, impact awareness, and early classification that sets oversight intensity. In requirements and design, you look for constraints, safeguards, accountability, and success criteria that reflect real harm pathways. In data acquisition, labeling, and feature work, you look for permissions, minimization, traceability, fairness awareness, and prevention of leakage. In development and testing, you look for disciplined change tracking, realistic validation, and evidence that leaders can understand. In deployment and monitoring, you look for access control, transparency, metrics that drive action, and drift detection that protects trust. In incident response, change management, periodic review, and retirement, you look for the operational habits that keep responsibility alive over time. When you think this way, AI stops feeling like a black box and starts feeling like a system you can govern with clear questions and evidence, which is the core assurance skill this task is trying to build.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.